I'm Serge Egelman. I'm a research scientist working with Dave Wagner in the Scrub Center, which is the Intel Science and Technology Center here on campus. So my background's in usable security, and basically what I'm interested in is how humans contribute to security problems, usually through poor design for human interactions when it comes to making security decisions. And so specifically, we've been doing a lot of work on mobile, and mobile is interesting because if not right now, then in the near future, more people are going to be doing computing on their smartphones and tablets than on actual desktop computers. And these devices are really interesting because there's a lot of data at their disposal. So the user experience can be really rich because it aggregates all sorts of sensor data, such as accelerometer, location, as well as personal data that might be on the devices, calendar, contacts, etc. But at the same time, this poses potential for major security problems when third-party apps might use some of this data inappropriately. And one of the things we've been looking at is how these different mobile platforms grant permissions to access this data to the third-party apps. And a lot of the problems that we see here in the mobile space are very similar to the usable security problems we see in general, which is that a lot of unnecessary security interactions habituate users. So when users are used to seeing lots of warning messages for things that they otherwise might not really care about, they then are trained to dismiss these when they show up for things that they probably should care about. The other problem is that users are often asked to make decisions about things that they're really unknowledgeable about and probably shouldn't really be knowledgeable about. And so a lot of the lessons here we can learn a lot from the classic literature on hazard avoidance. So, this applies to security in general. So at the first stage, we should eliminate hazards when possible so that users just aren't confronted with risks. And obviously, most of the time that's not possible, in which case we can design mechanisms to try and guard against the hazards through mitigations. And then finally, the last case is if we can't do any of this, then we should use warnings. And what we've seen in the mobile space with regard to permissions is that warnings that's just sort of the go-to step. And so we've done several studies, both in the laboratory and large-scale online surveys, to look at how users are currently understanding permissions on their mobile devices when installing apps, and whether they even notice them, and whether they take these into account as part of the app installation process. And so through this research, we came up with a couple different observations. The first was that on Android, but this also applies to other platforms, on Android there are several hundred different permissions that developers can request at app installation. Users see most of these when they install the app, regardless of whether or not they actually care about the underlying data. So too many requests habituate them. So the lesson here is maybe we should only prompt when necessary. Many of the users in some of our experiments were just completely unaware that permissions existed because they appeared too late in the process, after the user has already identified an app to install. Or maybe even they've already installed the app and are about to use it when permission requests come up. That's the case of Apple on iOS. And so maybe this information just needs to be provided earlier, when it's the relevant information that users care about. Finally, when there are a lot of different permissions, understanding what an application is actually requesting also requires some understanding of what it's not requesting. So maybe we need to narrow down the list of possible permissions to only the relevant ones. So building on this research, one of our observations is that all of the platforms tend to use only one permission granting mechanism. So in the case of Android, it's install time warnings. On iOS now, they have a couple runtime warnings when the permissions are actually requested by, when those APIs are called, they see runtime warnings. And the idea that I want to sort of put forth here is that maybe this is inefficient, and instead we should be choosing permission-granting mechanisms based on the underlying permission instead of this one-size-fits-all approach. So maybe there can't be only one permission-granting mechanism. So we've done some research looking at the different ways of asking for permission and came up with this flowchart, which we've now been using in our research. So there are several different questions that you could ask. So we have this notion of revertibility. So can the system revert to a previously safe state if this permission were granted. And if the case is yes, in all those cases, we should just be granting the permission and then providing some audit mechanism so that the users could undo the changes. And this goes all the way through to sort of the worst case, really scary permissions, which should only be represented as install time warnings because consequences might be severe, and those permissions might need to be granted at a future time. So, take the permission to destroy data on the device remotely. So anyway, our future work is validating this model and trying to improve how security interactions occur when they're needed, but also trying to come up with better audit notification mechanisms for the cases where we don't need to ask the user up front. So that's it.